So basically, guys, we stay, we listen, we compile what has been governed. Now, the risk policy, okay, basically, govern yourself, okay. A pomodoro by pomodoro, a goal, your target, a breath, you're breathing, a push, you rest, then you push your thing, then you rest, you rest, and go to do something else, you go outside or something, a go to a breath, a push to a rest, and then that's like a two-track Kanban. You research, you develop, or you research, and develop, and then you go MVP development, or you go foundational. So you have basic stuff, you feed everything, and then you find your aspirations you want to do outside. You want to achieve that day, like creativity witness. And then you can two-track systems. Okay, give yourself like a rifter. A rifter, chaos. Um, Give yourself like a rifter. Rifter is something like a governor himself. It reminds me of governance framework. So this is very important to start. So we get in Gosilang something called the Gosilang bitytate matrix. Matrix basically. OHA or OHA means OHA. Oh, basically it's not recording. It's not recording. It should be recording my okay. OHA means public in Igbo. So if you go to github.com/obnicholas OHA, that means OHA means public. Literally means public. Translated to public in Igbo. And then you got IWU, which means Iwu. Say Iwu. It means law in English. English, so public, law, and IJI, which means law. So basically, it's a governance model. So you got like a governance model there. So it's a solution concept. You got like the law model for law things, and you got the order, which is like IGA. So law and order, but in the public domain. You can get a private domain, but that's just we're trying to do public first of all. For because of Gosilang. So everything in public law and order, which is what you're gonna use to govern yourself with a specification. Where white paper, the white paper will be like a specification for some to tell you audience, someone you're writing for, or some audience you're writing towards, Gen Z, or someone that can understand the lingo you're speaking, the jargon you're gonna say to them. Technical expertise, whether based on the bidirectional gaming, bidirectional learning system equals phrase framework. Yes. So I'm gonna continue now. We got that already done. What else here? Yes. Okay, I'm going to basically the Hamiltonian diagonal solution. Or how IWU framework of a governance, via firm work or firm compliance. Now, the firm is there because we got law and order. We got policies. We got the order. If there's a firm miscompliance, that's what firm is. You order yourself. You can order yourself. You can govern yourself. The law is just there. You enforce the law. That's what firm is. Basically, I'm thinking of any lawsuits, anything that comes like that should just be you would think because you don't have to. If someone file a lawsuit just to use your service one day and don't, that's a big no. Use your service one day, you come back next day, use it for one day, you don't do it properly, don't follow the process, you don't valid customer in that domain. So I'm saying to you, the firm is the structure. It's like, you guys forget, basically, if you give you money to pay for something, you don't really accept it. You want to change the law around that, but it's a policy. But that's what I'm trying to do. The evolution of this kind of behavior is like entrapment. You're entrapped into a system that you haven't that's been built to against you. Which entrapment is like you can waste time on waste time on not complying with services. Biologically, using very local animation. So basically, you can prune the policies too. Allow for some kind of some compliance. Now, very important. Let me give you an example. So basically, if you go on an Uber ride, if I got basically, I had a dream. I had like a vision. Basically, I got in an Uber. If I get an Uber, I have some kind of new divergent interpretation policy, which is like an exception handling. Maybe I don't really understand the full policy compliance cycle because we don't use the policies anymore. But I want to get the results. So basically, I can interpret like if I'm driving an Uber car, I can drop it for someone else. Like he's autistic. I tailor two ways so he can achieve something. I can give him a right to his destination. He can pay later, and he can pay now and give him a right. Using the app, Uber app or like the app. But it's a two-way system to resolve that issue. Because getting to point A to point B shouldn't be a problem. If I'm driving a car for someone. But if I'm a taxi, the Uber doesn't do that. If I'm a taxi, it should be like that. It should always be pay here, pay now. It's too rigid. It has to be some kind of new divergent flexibility, especially people who are disabled, which I love. But I'm saying to you, the governance model works because of the new diversity as a first principle of the ecosystem compliance framework as a firm. But the firm, if the firm is too rigid, then you can't really govern yourself. So it's gonna be like a bipartite policy system to resolve systems of of sector models, like design, especially compliance and health and social care sector, something that's as a foundation to that framework. So basically, the target represents health, one sector, which is OHA, law, order, OHA, EU, EG, and then you got the order, the same one for the health, social care, OHA, EU, EG, IJI, the order system, for compliance with the DAG bypass the DAG system, to ensure the full compliance with the ecosystem, and how you can do this in Gosilang is literally just write at decorator and then at in quotes no hashtag no ghosting. And no ghosting means not losing the progress, in any way, shape, or form, and that will flag it up, based on the interpretation of the system. If I'm trying to ghost or I have some concerns or stress in it, it has to be utility to my mirror, who I am. No, it's not exactly. It's about biological red-black animation. So the red-black algorithm is, anything that's red, it becomes red. Still gets pruned, removed, and you get the black things, blackberries. That's red-black animation, self-sustaining governance model. So you can evolve directly to the objective too. For the system, so kind of it's a new anti-fragmented governance. Even though, no matter how you want to know the law, or try to go something, you can't break it because you can only direct you can only direct it up and above. One more option here. So that's what governance is. Basically all the standards, which is like the real word for version, semantic version, or a specification, something that evolves to above standards with a DAG standard resolution, which is a new architecture, new infrastructure, coherence, based on ontological analysis, or the ability found to do something without a hidden agenda to do that thing, and then the goal to doing that, whether they want money or to sue us, that's kind of thing we'll try to mitigate anyway. So that's something that's seemingly coherent with the Gosilang ecosystem, so the people can understand that the polyglot language is a real language, and it can govern itself with a decorator system. I will not be all sorts of bring me. I'll be working here also, which is my declaration of sovereignty via the firm oath I put, for the safety critical actually especially. But that's what I'm saying. It's basically how that works. Yeah. Okay, what else? Okay, basically you got the basically got the policy system which is called HITL, which calls human in the loop. Humans actively watching the project. That's human out the loop. Humans not actively working on project. There's no humans actively. Human out. That means out. But that's AI systems, the autonomous systems, the AI systems, things that are robots, things that are working but are not human entities, or sovereign entities. They're humans. They are conscious AI systems, but the verb now actuators can act in their own objective, and they do that. So basically, got the human on the loop system, and you got the human on the loop. That human that can actually work on it. So we can be a human on the loop. So basically, you got the foundation, the human on the loop, and you got a human in the loop who are working for a project or deadline or operation. Human on the loop, things that are just meant to just solve their own problem. Because these are just people that things that are meant to do it themselves and then fix themselves. And what you get like swarms, drones, or anything. Then you got like zero on the loop warning all the time. So you go like a 1, basically you go like -1 to 5, which for human out loop. You go like basically it's like a tripod, it's like a triangle, so a triangle, because you get like a center one, but if you go one direction, you get like the six. If you go to -1 to -5, in one section, one quadrant, it can be like a square grid between one quadrant of that section, of that trisection, of that bipartite diagram. You get like a 1 to 5, which is like a low, medium, low, medium, high, and high warning. High warning, and it's just warning. Now, when it's interpreted, you get the error, which is the error that you throw in the error, but it bubbles up to the code, and you get the bipartite resolution of the system, which is like the bipartite. What I call the interpretation of the system based on the languages for anti-hallucination coherence, which means like you can get you can obtain to have 2 interpretations of an exception. So which means like something you can try to handle, but it's not an error. It can be handleable. If it's an error, you'll throw an error, but an exception is not an error because it has to be accepted by the system. If it does pass with a try clash belt, it then continues and the wrong flows. But it's an exception because it can be wrong or right. But if it's wrong, he has to try the other route to ensure the system can continue. And then that one will be proved, the exception will get proved that doesn't work, and using red black animation, and then we can get a new exception to handle a new case, or add something to mitigate that entirely, and you get the panic systems. Okay, now you get 0, 1 to 5, low, medium, basically you learn warning, danger, critical, and fail-safe recovery, fail-safe or fail-safe one, and fail-safe one, which is fault tolerance, like a healing, the recovery artifact, and then a fail-safe two, which is like the killing the program silently, and then trying to crash the program silently, and you got fail-safe three, which is just immediately shut down. It has to kill itself. You really got this one. Try to recover yourself. You try to shut down yourself. If it blows up, before it blows up, kill the node. Based on the node that you're working on. That's like a warning, danger, critical, fault tolerance, fail-safe 1, and fail-safe 2 model certification. Now, 12 basically got 12 to 5, 12 to plus 5, which is 11. But what's my pen? 11 is like low to medium danger. Now, danger, and then you got 18 to 23, which is like a danger critical. Now you got 24 to 31, which is fail-safe 1, healing, 31 healing, and then 32 to 37, which is like a fail-safe 2, which is like the silently killing the process, just shut down the process aggressively, which is called aggressive shutdown. And then fail-safe 2, 32 to 37, which is like killing the project, killing that node and isolating the system state. NOV file silent failure recovery. You just isolate that node, that artifact. Isolation begins there. And then you can get the humans involved, human in the loop. Basically, there's a mapping to the system. By the basically, if the system fails, the human out system, the ES fails, you can get the human. If the human fails, the human in the loop fails, then you can get new humans onto the loop, and then can become like a bypass attack resolution based on clustering algorithms to ensure people are complying with the policies already there, etc. etc. Then we get that down. And what else have I got here? Yes, absolutely. Okay. Okay, basically we got that already. Okay. Yes, basically the Gaussian UML is there. Segment trees. No, something I'm missing here. Okay, yes. So basically, UI here, that'll be monoglot, hybrid, and polyglot. The UI never needs to touch the code in the background. Basically, you can fork a process, and the forking can be like have a PID file. You can log that PID file. But the Gosilang PID for process ID files are pinned. So you can pin the files to the Gossi framework, and you can show that framework is locked, so you don't unpin it. You don't have to reshuffle based on what the observer, to get that system or that effort to adopt that artifact, because the system understands the schema already in place to resolve that artifact, because that schema is a service dot operation that your domain dot my one OP-nexus dot operation dot division dot county local Iwu county dot org, based on the governor also framework bidirectional layer. The service are just the service that people can buy. The operations are things that humans are working on. Then you got like my domain OP-nexus. They got like the operation, the department, human rights department, sales department, division, computing, which as a bi-direction, the county, like the local county, the low county, or the Oha county, or the something that the road name, the road, something that can be decentralized, so it's not decentralized mapping, or the execution pipeline. The thing about this model, what's the time now? Is that there's no way to there's no single point of entry to failure, because if something is centralized, it's just one way to fail it. But it's about decentralized polyglot information system, because there's no banks, no nothing there, because everyone's just solved that, but just a problem with ledger acknowledgement. Genetic makeup, phenotype, biological. Architecture as infrastructure. Basically, the minimalist architecture equals to infrastructure. So basically, what you see is what you get. But that's the principle of UI UX design. What you see is what you get. But that's what basically what you try to drag and drop a WordPress site. What you see is what you get. or Dreamweaver applications, if you use Dreamweaver. But if you type HTML code, what you mean is what you get. That's just, the dilemma. But we use both in the architecture as infrastructure, based on minimalist. Basically, every time you write code, the genotype has to adopt this. So what you see is what you get. Genotype model to ensure that anything that's written down has a resolution. Resolution is like needs to work coherently. And can speak to any language, the computation, geometry, architecture, as well as phenotype model. So basically, we see the coherence operator as an infrastructure, as an architectural compliance of the structure of that ecosystem. You can check the proof because the usual post is in blue, is in blue and blue or blue screen, or like some kind of architecture, some kind of apply UML or diagram. For modeling the straight safe programs, based on the bi-tight duplex streams, bi-parted duplex stream, uses recovery to map segment trees and interval trees to updates on time. Now, how Gosilang updates, basically, if you're not working on something, you have to update, so you have to calculate time. I told you that in my last video. But the goal of that is really you can update, you can run systems, you don't even have to integrate the system. You can still to never integrate. If the system is strong enough, you don't need to touch it. Just update and fix the job. You can set up accounts, restore accounts. It doesn't really matter because there's no need to clean up an entire database or an entire infrastructure to start again. If people leave, that's the whole idea of that rollback animation and that bypass resolution for real world humans. Zero node execution, cluster systems. What else am I running? So that's my PhD in motion. Yeah, I haven't got anything else I'm writing down. Try information. What you see basically, the schema is like the mapping of the actual the blueprint. The genotype model resolves that architecture independently of the system. If the node is degrading, anybody needs, basically you can have like a dynamic algorithm that heals one model in order, has priority to heal something. Because if the node is or some kind of component library needs more attachment, it can be exhaustive for the system to parallelize that and load balance that. There's no need to load it. Usually, if you delegate services to the useful services people are using it based on what is really trending there, like the bi-directional, what I call it, the bipartite search engine page ranking system. To ensure that people that are getting there what they need, because I can say something like I need something in one domain, but no one is in the other domain. But because my own purpose, it doesn't be trending for me, I'm trending for others in Japan or something. But it's all demographically locked, so you have to tell it what I need at that time because I need to get on with my life. The architecture infrastructure of the public system has to comply with the matrix systems there. Okay, now let me continue reading. I'm gonna read some code today. So this is like a Gussie, this is Guinea, the parrot, it's Guinea Gini. This is Lepalico, and you get like a Guinea and Lepalico. This is like a Guinea, the mascot for the polyglot programming language, and Lepalico, 18. Now, the Paromado, this is like the Paromado, basically. Okay, basically. This is just me writing stuff. Basically, complexity was really, basically the Gosilang bit. This is like I'm saying. This is not really complete. Basically, this is the first one, the Rifter's Way. But this is just the Rifter's Way. But the other one is called the Gossipers. The gossip. Basically, this is the Guinea the parrot. But the thing is like when the compiler processes you breathe. When you breathe, the system preserves. Input takes no data, but your last exhale, your last breath. That's just Rifter's Way. There. But I'm gonna try to get the. If you go to my okay, basically my video, I can still make a video here. It's not really moving my mouse really. I think I have to stop this video, guys, because my mouse. Okay, guys, let me just stop this video. Okay, let me stop this video, guys. 3, 2, 1. Because I need to stop this video to make another one. Because the is going slow now.